All right, everyone, I'm going to go ahead and get started. Welcome to the California-Nevada Drought Early Warning System Drought and Climate Outlook webinar for September. Thank you to those that have joined us previously and those who are joining us for the first time. My name is Amanda Sheffield, and I'm from Scripps Institution of Oceanography in San Diego, and I'm the Regional Drought Information Coordinator for NIDIS in California and Nevada. This bi-monthly webinar series is designed to provide the region with timely information on the current drought status and associated impacts, as well as a preview of developing climate events. This webinar is being recorded, and the recording, along with the presentation slides and a 2-page summary flyer, will be available on drought.gov later this week. Just for a little background or rebriefing for those of you who've been here before or those who haven't, the National Integrated Drought Information System is a way to provide better understanding of how and why drought affects society, the economy, and the environment. So we work to improve accessibility, dissemination, and use of drought early warning information for drought risk management. We do that by working with experts in the networks, partners in the networks, of these different regional drought early warning systems, working towards creating a national drought early warning system. What is a drought early warning system? As I said, it uses these new and existing partner networks to optimize that expertise and across federal, tribal, state, local, and academic partners to make this climate and drought information and science and impact data available, easier to understand, and usable for decision making. And we also do this by working to improve the capacity for stakeholders to better monitor, forecast, plan for, and cope with the impacts of drought or climate events, and such as webinars as these. We have been around for a little while. California was established around 2010 with Governor Sandoval in Nevada, helping us bring on Nevada in 2016. We do have a strategic plan that's now up on the California DEWS website. It's not meant to be the end-all be-all for what we're working on. It's actually rather dynamic, and we have projects and partnerships that are developing always on the why we work through the plan. And we had our first annual coordination workshop in June, which gave a chance to bring all the partners together that are working on the region on these issues and see what our next steps should be. If you're interested in getting more involved with the drought early warning system, please feel free to contact me. Otherwise, I'll go ahead and introduce what we're going to be talking about today on the webinar. First off, we're going to have the Drought and Climate Stats Update by Dave Simrall, who's at the Western Regional Climate Center. He's also a U.S. Drought Monitor author. I will actually be providing the Drought and Climate Outlooks this time. We'll also have an update from the Southwest Fisheries Science Center from Miles Daniels on some of the tools they've developed, as well as a status update and explanation of what is the subseasonal climate forecast rodeo that the U.S. Bureau of Reclamation are doing, and Ken Nowak will talk about that. It's being hosted on drought.gov, so we thought it was a good chance to let them see how the forecasters are doing as part of the forecast rodeo. With that, I'll go ahead and pass it over to Dave to give the first presentation. Dave, if you're ready.
Yep, I'm ready to go. Let me know if you can see my screen.
Yep, we're good to go.
Okay, let's go back one here. Okay, are you seeing this on the corner of the screen? Sorry, the box that has the attendees and so forth, because it's kind of right in the middle of my screen.
Nope, we don't see that. But if you hit the little orange arrow at the top of that box, okay, it'll hide the box for you.
Sorry about that. Okay, so I wanted to start out taking a look at the current U.S. Drought Monitor map that just came out last Thursday. So looking at the western United States regionally, to date, we've got about 21% of the region in drought. We've seen some substantial improvement since last year at this time, where about 32% of the region was in some form of drought and 58% 2 years prior. With the wet winter we had, we saw a substantial improvement in our neck of the woods here. Kind of the focal point of drought regionally was up in Montana this summer and northern plains, where Montana experienced its second driest summer on record. We saw some improvement in drought conditions in Arizona and New Mexico with a wet wet month in July in Arizona, and some lingering long-term moderate drought conditions in southern portions of California, and Nevada is currently drought-free. Sorry about that. There we go. So taking a look at a little more closely at California and Nevada, about 8% of California is currently in drought, and you can see those areas down in the southern portion of California along the coast, as well as in the southeast corner of the state. Nevada is currently drought-free. On the bottom, those are time series graphs starting in about 2000, showing drought conditions in California as well as in Nevada. And you can see the impact of this past winter upon drought conditions. We've seen substantial improvement since the beginning of the year. This is a change map looking at improvements and degradation in drought conditions across the region. As I mentioned, kind of the focal point of drought was centered over Montana and Pacific Northwest, and you see some pretty serious degradation in conditions in those areas. And as I mentioned before, we've had some lingering drought in along the southern coastal plain, down in the kind of Santa Barbara area, as well as in other portions of Southern California, where we've seen some reservoir levels that have not recovered, as well as groundwater conditions. Those areas didn't experience the record year that some other portions of California, record precipitation that those areas did. They were closer to normal in those areas. So taking a look at some NCEI temperature and precipitation maps. On the left, we have mean temperature percentiles from the beginning of the year through August. And as you can see, nationwide for CONUS, we've been above average temperature across the country. It was the third warmest January through August period on record, about 2.8 degrees above the 20th century average. And on the right-hand side are the precipitation percentiles for the same period. As you can see, it was wet across many regions in the country, not only in California and Nevada, also portions of the Pacific Southwest or Pacific Northwest, the Gulf Coast region, and the upper Midwest and portions of the Northeast. It was the wettest on record for that period. So kind of the story of the summer, as most of you know, is the extreme heat in the region. And this is because we had a strong, persistent upper level ridge that kind of dominated conditions across the western U.S. This summer. And this ridging brought above normal temperatures to much of the western U.S., as well as really dry conditions up in Montana and into the Dakotas. And on the bottom, you can see these are 500 millibar geopotential heights and anomalies. And we have June on the left, and you can see the ridge was kind of centered over the Great Basin and Southern California, and it's a little bit westward of where it's normally positioned in the Four Corners area. As the summer progressed into July and August, it shifted a bit northward into the Pacific Northwest and a little bit offshore of the Pacific Northwest come August. Looking at temperature rankings for the summer, it's warm across the entire western United States. It was the warmest summer on record for both California and Nevada in terms of average and minimum temperatures. It was the second consecutive summer California has broken its record for the warmest on record, and the last four are amongst the 5 warmest on record. We had a number of record-breaking temperatures across the West in July for the records for the month, including Bakersfield, Reno, and Salt Lake. And it was not only warm in California and Nevada, but it was the second warmest summer on record for Oregon, third warmest for Utah, and fourth warmest for Arizona and Washington State. We had a number of heat waves this summer. These are kind of, bracketed some time periods, but in general, we had several of these heat waves. The first one, most of you probably remember back in late June, where we had record heat across the Southwest, including Vegas and Reno and San Francisco. We had it was so warm down in areas of the Southwest that in Phoenix, planes weren't able to take off from Phoenix Sky Harbor Airport. We had some heat waves in the Pacific Northwest in late July into early August, and then again another one in late August into September, where San Francisco Airport hit 104 2 consecutive days and broke an all-time record for hitting 106 degrees on September 1st. Taking a closer look at the temperatures this summer. So on the left, this is a percentile map from the Westwide Drought Tracker. And you can see the warm color areas. The darkest red are areas of record temperature. So you can see warm weather kind of dominated in the northern portion of California, as well as the western Great Basin and south central parts of Nevada. The two graphical representations that I have there are mean temperature departures from June until August, and you can see that for the whole period of record starting in 1895, we had pretty substantial temperature departures, which has been the trend since about 2000, and we were about 3 to almost 4 degrees above normal in terms of temperature, average temperature departures for the summertime. Taking a look at the last 90 days, on the left side are maximum temperature departures, right side minimum temperature departures, and you can see we were pretty much above normal across most of the western United States. Moving on to precipitation, starting from the beginning of the year, I have 4 maps here showing the precipitation rankings. We were, as I mentioned earlier, the wettest on record nationally in terms of precipitation, January through August. Regionally, 7th wettest on record. Statewide, California was the 6th wettest for January through August, and Nevada the 13th wettest. Since we're about at the end of the water year, this is a Westwide Drought Tracker map taking a look at precipitation for that period. And as we all know, California was well above normal across most of the state, and we had some record-breaking accumulations across Sierra Nevada, kind of the extreme northwestern part of California, as well as western portions of Nevada and north central portions of Nevada as well. Looking at precipitation this summer, California generally was pretty dry June through August, except for some isolated areas in northern California, as well as some areas in southern Nevada where they had above average precipitation. Taking a look at the North American monsoon, the core region we experienced, which generally speaking is Arizona and Nevada, and it kind of creeps over into the southeastern portion of California and southern Nevada. But that was above normal precipitation in July and in eastern and southern New Mexico. August we saw a drying trend, except for in eastern New Mexico. And California in general had a kind of a weaker monsoon than normal, but there were some areas in the eastern Sierra that experienced above normal to near normal precipitation. In Nevada, normal to slightly above normal in western and southern portions, and normal to below normal in the northeastern part of the state. We had some unusual weather events during this month, including most of you probably heard about the microburst in Santa Barbara Harbor that occurred on September 3rd. And this was in association with remnants from Tropical Storm Lydia. We also had some severe thunderstorm activity along the central coast in San Francisco and western Nevada, as you can see in the upper left photo of San Francisco with some rare lightning that you would see in that neck of the woods. Below that was a photo taken on September 11th. That's looking southward towards the Carson Valley from Reno. And there was also a funnel cloud, which is quite anomalous. It was spotted over Lake Tahoe on September 13th. In terms of wildfires, on the left we have a map of wildfire activity in Nevada. The larger circles represent larger fires, smaller fires, and kind of put a box around it. And just qualitatively speaking, if you look at the precipitation map for October through August, you can see those wet areas in the darker green, and they kind of track with where the wildfires were. So we had a lot of fine fuels that grew and were available, and most of those were probably, I think, were lightning-started fires in northern part of the state. So it was an active fire season overall. According to CAL FIRE, in 2017, we had about 7,000 fires in the state and about nearly 750,000 acres burned, which is nearly twice the 5-year average for the same interval. And in Nevada as well, we had a very active fire season with about 4,000 fires and 1.9 million acres burned. Looking at current streamflow activities, as expected with a wet winter and the snowpack that we had that extended into kind of the mid portions of the summer, streamflows are normal to above normal across most of California. Looking at Nevada, stream flows, same thing, well above normal in the Carson, the Humboldt, Truckee, and Walker rivers. Moving over to reservoir storage, overall, California's major reservoirs are all above normal. We have one that's below normal at Oroville, but I think that's in relation to the construction activities related to the damage that occurred to the dam this winter. So I think they kept the levels lower than normal. Looking across the west, reservoir conditions are above normal in every state in the west except for New Mexico and Washington. Moving down to the lower Colorado River Basin, Lake Mead is currently 39% full, so had a slight increase over last year as there was above average precipitation in the headwater areas of the Colorado River. And Lake Powell is currently 61% full. As I mentioned earlier, with some of the lingering drought on the drought map in Southern California, that's in relation to some of the groundwater activity that groundwater hasn't recovered in areas of the southern coastal plain, Inland Empire, and in the LA Basin. And we're also seeing below normal wells in Amargosa Valley, Carson Valley, and the Fallon area within Nevada. And that about wraps it up.
Thanks, Dave. But while I'm switching over, I forgot to mention at the beginning that if you have questions, feel free to type them in the questions or the chat box. If we're able to get to some quickly while I'm changing speakers, we will. Otherwise, we'll save most questions for the end. But Dave, here's a quick one maybe you can do while I'm switching over to me. Regarding the summer mean temperature trend, how did the trend in daily min and max temperatures change relative to the mean?
How did it change in terms of compared to the mean temperatures?
How did the trend in daily min and max T's change relative to the mean? I'm not sure.
Well, we saw, like I said, we saw a record, go back to it, we saw record mean temperatures across much of Northern California and the Western Great Basin, as well as areas in the Central Valley and along the Central Coast as well. But I think the trend that we've been seeing for a number of years now is the average minimum temperatures have been above normal, and those have been creeping up over the years, and we're seeing greater departures in the minimums, more so than the maximum temperatures.
For that, I'll switch over back here to me. All right, so I will be reading the Drought and Climate Outlook today. As I said, my name is Amanda Sheffield, and I'm with NOAA NIDIS, but I sit here in California at Scripps Institution of Oceanography. I am an atmospheric scientist by training, but since earlier this summer, I've moved on to work with NIDIS, previously working with the regional research program, CNAP. Today, mostly I'm going to be talking about what we do know so far in the ENSO observations and forecasts, and also then the subseasonal, seasonal temperature and precip forecasts that we currently have. Before I get started there, I wanted to do maybe a little refresher on what exactly is seasonal to subseasonal forecasting, to get us all in the right mindset before I move in to discuss what factors come to play into those forecasts. This is a figure by Columbia that is an interesting way of looking at how we have forecast skill versus forecast lead time. Longer-term climate forecasts from 2 weeks to 12 months from now are usually what's categorized in subseasonal to seasonal forecasting, or S2S forecasting. They utilize information from computer models, statistical models, and the best of our knowledge of how the atmosphere, ocean, and land conditions work. The skill or accuracy does vary with season, region, and depending which variable you're looking at, such as temperature versus precipitation, and how far out you're looking at forecasting. For example, here you can see we have weather forecasts, which are in these less than 2 week time frames here. And they primarily get their skill and their information from the initial atmospheric conditions, compared to subseasonal forecasts in these 2 weeks to almost 2 month time frames, where it's looking at these shorter term climate, such as Madden-Julian oscillations, land surface conditions, etc. And longer seasonal forecasts use these ENSO state, or the El Nino Southern Oscillation state, to start to think about what are these large-scale climate factors and how they affect what our precipitation and temperature trends will be. This is the reason why when we get further into the presentation, you'll see that we give, because it's harder to forecast in these time frames, we are given more in, say, probabilities of what is going to occur versus exact forecast values, like what will the temperature be, what will the exact precipitation be that you're used to in your weather forecasts. As I said, one of the factors that comes into it, and the one we've talked about, obviously, if you've lived here for a few years, is what is the El Nino status, or the sea surface temperatures in the Pacific area. Here's just a recap since 2000, how we've been doing to think about, give us the right time frame for how we were doing last year and into this year. If you look like here, last year was when we were in that weak El Nino conditions of 2016 to 2017. They were weak El Nino into neutral range, and we've been in the neutral range almost completely since then, with some warming in those SSTs in this Pacific region here of the Pacific Ocean. Those we have been dipping down, though, into these cooler areas. We are currently still sitting in ENSO neutral, but during the last 4 weeks, below average sea surface temperatures have started to grow across the central and eastern Pacific. Here are the weekly averages of the sea surface temperature anomalies, so they're different from the normal. And you can see these blue colors start to show where we're starting to have cooling as we move from August into September, and that's varying from what we had over the summer. This has been linked also to below the surface. We're seeing this as well. So we've seen a downward trend over the late summer in the sea surface temperatures as well as below the surface, which is linked to the trade wind trend. So we're starting to see a hint of La Nina right now, even though we're in an El Nino state, or sorry, a neutral El Nino state. So how does the forecast look though? So that's sort of where we're standing right now. Is that we have ENSO neutral, but we are in a La Nina watch. Here is different plumes of different dynamical and statistical models that are looking at how will that state change go into the future. So each line here is a different model. And I've highlighted here these darker colors is this La Nina range, where this greener color is the neutral area. So you see most of the models hover on this edge of neutral to weak La Nina area. So that's currently where we're sitting. This was similar to what we had last year, for example, where we were sitting here whether we didn't know we were going to La Nina or neutral conditions. And I want to mention that back-to-back La Nina years are not uncommon. They've occurred at least 5 times since 1950, and the last time was actually between 2010, 2011, and 2011 and 2012. So the reason why we're in this La Nina watch is because conditions have started to cool in these sea surface temperatures, so we have the physical evidence that we're starting to possibly move towards La Nina. And also this time of year, we do have a higher degree of forecast skill for ENSO for these sea surface temperature conditions that's leading into what these models are saying. So the current forecaster and model consensus, which is the figure here, shows what are the probability of La Nina in blue, neutral in green, and El Nino in red across these different time periods. So we have August, September, October, November, October, November, December, etc., into our winter time period here. Since we are starting to see these conditions and the possible cooling, right now La Nina is favored to possibly form this winter, 55 to 60% chance. But there is still a chance that neutral conditions will remain, and we'll have to watch the conditions closely and see how they change for the current forecast. As I said, ENSO is only one factor that can determine what our temperature or precip patterns will be for the year. So this is an example of the whole state for California, what our ENSO status has been, El Nino, neutral, and La Nina, and what our October to March precipitation has occurred previous years. These figures are from the Western Regional Climate Center, and they haven't quite updated yet, so I put a star here for where we were from the 2016 to 2017 year. As you see, even for statewide, even if we're in this La Nina or neutral year or on this edge, we've had a large spread of different types of events here, from dry to very wet winters, including last year. So it's really, even though we're moving into a possible weak La Nina year, we don't know exactly for sure what's going to happen in terms of precip. I'm including one more region here for California for a similar figure, here for the Central Coast area. Since this is one of those areas closer down here, Santa Barbara as well, that's still left in a D1 category of drought, I chose this one to show where we were last year, but also the spread in the possible conditions we might have with these types of ENSO state that we're seeing. And then not to leave Nevada out here, I chose the Northwest region and the Southern Nevada area to show how the spread for those conditions have been as well between these neutral to weak La Nina years. Last year, actually, the actual amount they had in Northwest Nevada is actually off the charts, the current version of these figures. And in Southern Nevada, you can see last year wasn't quite as groundbreaking for them, and it's actually sort of in the pack of all these different conditions we've had there before. And so the reason I included these to sort of show that while we can look at this ENSO state, it's not the only factor that's going into how the forecasts are showing. And so we don't have a ton of information of how this year's going to go yet. We'll have to follow it as we go along. But we can show you what we do have so far. So next I'm going to move into the Climate Prediction Center forecast. Before I do that, I thought I'd give a quick refresher on how to actually read these diagrams. At the request of a couple different partners in our region, including California Department of Water Resources, we have a 2-pager at CNAP that shows how to explain these forecasts and how forecast skill in that diagram I showed earlier on. So I'm going to go ahead and walk through similarly to this one, to what our current forecasts are showing, to highlight and help you remind you how to actually read these diagrams. So here we have the October, November, December temperature outlook from the Climate Forecast Center. These were made on September 21st, so just last week. And the different shading on the maps show the favored probability for that region. So for example, a forecaster starts by assuming that at any location there's an equal chance of above normal or below normal conditions, normal being what they saw from 1981 to 2010. Forecasters then use the tools that they have access to decide how the odds shift into favor one category or another. So for example, here in the Sacramento area, it's shifted to above normal temperatures are forecasted for October, November, December. That above is a 37% probability right now. It doesn't mean that below or normal conditions don't exist. It just means that we're favored to have above warmer temperatures in Sacramento. And even warmer in, say, for example, Las Vegas here, where the above normal probability is or odds is 45%. But it's not out of the question that below or normal could occur. It's just that above is favored here. And I'll also remind you that these figures don't show exactly how much warmer or, for example, cooler other versions that these regions will be, but instead gives you a sense of whether it's favored to be warmer or drier, etc. for these times of year. So to move through the rest of the seasons, this is the same figure you just saw for October, November, December, and then as we move through November, December, January, and December, January, February, we see these trends continue where we have higher odds for warmer than normal temperatures in the region. To look at precipitation, as I said, it's pretty hard this year, so we don't have tons of information within the climate factors, but using what information we have. Currently, the forecasters are showing equal chances in most of California and Nevada. That means we have equal chances of above, below, and normal precipitation in the region. There is this area here in northern Nevada and northeastern California that is into the above precip forecasted area. That means within this lighter shaded area, there's a 33 to 40% chance of above normal precip, but there still are odds that we may have below or normal precipitation. And those trends are pretty consistent across November, December, January, February for the region, where this more northern part of our California, Nevada region has the highest likelihood of being above normal precipitation. And then lastly, this is the seasonal drought outlook. As they are using the similar information to what I just showed in the other figures, they consider drought to persist in these D1 category areas in the Central Coast and Southern California areas, with no yet unknown, with no forecasted currently for drought to develop in certain areas or things like that. This will improve as we move further through the season, and we'll have a more accurate way of estimating what's going to occur. And that's mostly what I had. So basically, we are looking at these seasonal forecasting timeframes, which do use climate factors such as ENSO to forecast them. La Nina conditions for this water year have been forecasted, but it's currently the tropical ocean atmosphere are in a current state of neutral conditions. We have seen that recent downward trend in sea surface temperatures, which has given us the physical evidence that we might be going into La Nina conditions. But the models are projecting a 55 to 60% chance of La Nina this fall and winter. Obviously, ENSO is one part of the seasonal forecasting toolbox that we have, and so we'll have to wait and see a little bit more how this season develops. But as of right now, the CPC is forecasting for California and Nevada to have above normal temperatures this winter, and most of the region has equal chances of above normal and below normal precip. I encourage you to keep in touch with your local weather service offices, as well as us here at NIDIS and other NOAA programs and partner programs throughout the region as we move this winter to keep tabs on how we're doing and what's coming up. With that, then I will pass it on to our next presenter, who is Miles Daniels from the Southwest Fisheries Center, to give us a bit of an update.
Great, thanks, Amanda. Can you hear me?
Yep, and I just passed control over to you, so you should have it.
Great. So thanks for having me. My name is Miles Daniels, and today I'm going to talk to you a little bit about a decision support tool we're developing at the Southwest Fisheries Science Center, really focused on understanding water temperature dynamics in the Central Valley of California. So sort of specific, but certainly adaptable to other regions of the state and other states around us. And I also want to give a quick update on how a certain salmon species in the Central Valley responded to the recent multi-year drought in California, just to give everybody an update. So to begin with, if I can change my slide, I figured I'd start with just giving a general update on the numerous ways the drought can affect fisheries. Of course, a lot of these are interacting and widespread, but we typically think about things such as reduced flows in streams and rivers. This can also be linked to increased levels of disease and disease spread, which can also result in reduced food availability and habitat availability as streams dry up and fish become stranded. And today we're really going to be focused on one of the effects of drought related to fisheries, which is poorer water quality in regards to water temperature. So typically when you have drought, you have less water, warmer air temperatures, and this results in increased stream temperatures, which can impact certain life stages of certain fisheries, especially cold water fisheries in the Central Valley of California. I also want to just use the slide to kind of highlight a little excerpt that came from the West Coast Fisheries Office of NOAA back in 2014 during the height of the last extreme drought in California. And just to highlight one point that they talk about, which is one of the ways that NOAA works to protect fish in the Central Valley against extreme drought is to work hand in hand with other federal agencies, state agencies, local stakeholders, et cetera. And that kind of provides a reason to develop decision support tools so that all these different agencies can have access to the same information when making decisions on operations of the system and understand how maybe changing shafts of the dam operations will affect water temperature downstream. So I realize everyone's probably not focused on the Central Valley who's listening on this call, so I figured I'd give a little bit of an update or a little bit of a introduction to the species that we focus on at the Southwest Fisheries Science Center in Santa Cruz, California. And that's winter run Chinook salmon, which are an endangered species under the Federal Endangered Species Act. And the population that resides in Sacramento is essentially the most southern extent of winter run along the west coast of the United States. And essentially, this map to your left here shows you their current and historical distribution in Sacramento River. And one of the things you notice is this blue line is their current distribution, and this black line is their historic distribution. And what you can see is around Redding, that's where that change occurs. And that's ultimately because there were two large reservoirs that were put in place back in the 1940s, Shasta Dam, Shasta Reservoir, and Keswick Reservoir, which essentially blocked these winter run Chinook salmon from migrating further upstream into cold spring-fed systems. So essentially these reservoirs shifted the spawning grounds of these salmon further downstream into the watershed where they're experiencing warmer conditions than historically they would have. And now that they're below these reservoirs, they're essentially completely reliant on the water that's being discharged from these reservoirs for their survival. And this becomes really important during early life stages of their history or life histories when they're developing from eggs and reds into fry, and they're very susceptible to what's known as temperature-dependent mortality if water temperature goes above some threshold. And this also relates back to drought in that since they're below these large reservoirs, in times of drought when these reservoirs have low volume and low cold water to work with, you can have some situations where there's just not enough cold water resources to go around to supply these fish with their needs. So as a quick update on the drought effects on winter run, I just wanted to show you this slide, which was also produced by the West Coast region at NOAA Fisheries. Essentially, there's two columns here representing two different years. One is 2011, which was a very wet year for California, and the other is 2015, which was a very dry year for California. And there's a few different statistics shown here. In the figure here at the top, you see the number of eggs estimated to have been spawned between Shasta Dam and Red Bluff Diversion Dam. And so we can see in 2015, there were about 5 times as many eggs estimated to be spawned in 2011. So about 10 million compared to 2 million. But then if you look further down and you look at the estimated rates of escapement or survival from egg to fry past Red Bluff Diversion Dam, you see that even though there were much, much more eggs in 2015, the survival past Red Bluff was much, much lower, around 3% compared to 41% as they moved down into the Delta. So this slide, I think, does a nice job of just emphasizing essentially the effect of drought can be that even though you have much more eggs to work with drought effects really reduced the overall population survival for that brood year. And you might ask, well, what was the cause? Was it just because there wasn't enough water? Or was the water too warm? And some of the work that's been done at the Southwest Fisheries Science Center has really pointed to water temperature being a critical driver of this survival estimate here. And essentially in 2011, you probably had a nice cool water, which allowed 41% survival, while in 2015, the water was likely just too warm and resulted in a high rate of temperature-dependent mortality. So that sort of brings us to kind of our impetus for wanting to develop a decision support tool focused around water temperature, considering that water temperature seems to be such a critical driver for survival of the species. So it's really important to understand how water temperature dynamics occur in the system in order to manage the species. And so we decided to develop a suite of water temperature models and essentially broke them out into 3 different domains, which represent the physical domains of the Sacramento system that we're working with. And we push all these outputs of these water temperature models to a website to allow other people interested in their output to access them and to evaluate their output in terms of different operational conditions, et cetera. And so this is just the homepage of the website that you would go to. And I can take you there. I think it will work. I can take you there now so you can see it in real time, because essentially we update these models on a daily basis. So they ingest new meteorological conditions, new hydrological conditions of the system, and we rerun the models every morning so that we give stakeholders essentially the most up-to-date information we can at this time. And so if you go to this website, you'll see there's a little description of some of the, essentially what's the purpose of the website. If you scroll down, it shows you the domain that we're working in, and you can click on different things such as where Shasta Reservoir is, and it will take you there just to get oriented with the landscape. And then there's some other tabs to the left here, which basically point out the different domains that we're working with. So we have a watershed model, a reservoir model, and a river model, like I talked about before. And when you click on those tabs, you're taken to some of the model output, which I don't have time to go into today, but ultimately this gives the user ability to look at things such as if I'm interested in water temperature at an hourly time scale at certain locations along the river, I can scroll through these and say I'm interested in Ball's Ferry temperature, which is known as the temperature compliance point. And I want to ensure that the daily average temperature is below 56 degrees, which is a kind of a regulated temperature control point. I can use this to say, oh, yeah, well, the model was updated today. This is a forecast skill setting, which just kind of allows us to assess how well our model does, which is in blue compared to observations. And then we can look out about 7-8 days and see what we expect the water temperature to be at this location given updated meteorology, hydrology, et cetera. And so I'll leave it to hopefully you joining this webcast to explore this website more. But the other thing is that I just want to let people know is you can download all this information from that we're producing and use it in other water temperature models, perhaps compare how we're doing compared to others, or other biological models if you're interested in things such as water temperature. If I can go back to the main slide. And so that's all I really have to share. I just wanted to leave with one piece of information that was put out in a NOAA report recently about the success of water temperature management in Shasta Reservoir. This is just kind of an excerpt from one report showing that in 2016, due to successful water temperature management of Shasta Reservoir, it was estimated that winter run Chinook salmon temperature-dependent mortality was approximately 2%, while in 2014 and 2015, it was maybe around 77 to 85%. So this just kind of shows you that with more tools available in terms of water temperature modeling and providing the output from these tools to managers, there is really potential to reduce the impacts of temperature-dependent mortality and hopefully allow this species to persist in multi-year drought conditions. And so with that, I'll take any questions if there are any.
Great, thanks, Miles. I don't see a question right now, but it doesn't mean there won't come one later. So with that, I think I'll go on to Ken, and then the speakers will all be around to answer questions if you have some to come the way. So thanks, Miles.
Yep.
Switching over to Ken now. Ken is with the U.S. Bureau of Reclamation and sits in their Research and Development office.
All right, how does that look?
Great.
All right, fantastic. Yeah, thanks very much for the opportunity to present. I'm with Reclamation in the R&D office, as was mentioned. I think most of you are probably familiar with Reclamation, but a real quick orientation for those of you who may not. Reclamation operates only in the 17 western states. We're part of the Department of the Interior. 337 reservoirs, depending on how you count them. The largest wholesaler of water in the country, second largest producer of hydropower, and you can see our projects scattered across our 5 regions there. So really we're trying to manage, develop, and protect water and the related resources in an environmentally and economically sound manner in the interests of the American public. As you kind of heard today, water management frequently has multiple objectives, sometimes competing uses, and so we're trying to seek an equitable balance. One of the things that will help us achieve that mission and maximizing the use of that water is forecast information. So that's sort of where we're coming from with respect to this initiative. So really quickly, I'm going to talk about price competitions. You may not be familiar with that. I'm going to talk about seasonal forecasting a little bit, and then I'll get to this competition, the Rodeo, that we've been hosting for the past couple of months. So price competition is a way of essentially crowdsourcing a difficult, challenging topic. Private industry has been using this for a while. Challenge.gov is the federal clearinghouse of federal competitions. Federal agencies have been spinning up with price competitions since about 2000. A lot of other agencies, including kind of got on board about 7 or 10 years later. And so much like data.gov, you can find all federal challenges here. And the idea here is that you want to issue a challenge to solve some sort of specific, typically challenging problem. You're using monetary or other incentives as a prize. And typically the way it's structured, the winner must achieve a predetermined performance metric established by the sponsors. That can be qualitative or quantitative. And pretty much anyone can compete at their own risk. You're paying for performance, not potential, which is a different paradigm than a standard sort of research approach, which our office certainly employs also. And anyone can compete at their own risk, exception being folks who are already being funded by the federal government, either through grants or their current positions to do this type of work. So if you're already supposed to be working on, for instance, improving S2S forecasting, you may not be eligible for this competition, but that's the general idea. The Reclamation R&D website has a water price competition center. It's where you'll find out about current, past, and upcoming competitions. So if you're all interested,
stop you a second?
you can. Yeah.
We're getting, I think, a little bit of a weird feedback on some of our audio. Do you think it's because of your Wi-Fi, or you're just not close to the computer?
I'm on, so I don't think it's Wi-Fi.
Oh, you're on the phone. Okay, sorry. Okay, I don't know if there's much we can do, but it's just breaking out a little bit every once in a while.
Okay, I'll do my best to speak clearly into the mic.
Okay, thank you.
Yeah. So anyway, we have a website, webpage dedicated to these competitions. That's all I was pointing you to here. So what's the relevance to the reclamation of subseasonal forecasting? We're a consumer of this type of information, and as you all are aware, over the past 8 years, pretty much all the West has experienced drought affecting the economy in a variety of ways, impacts to agriculture, production, water supply, energy, etc. So really that's a critical part of our mission, is managing those resources to hopefully minimize the impact of drought. And so better information at the subseasonal or longer time scale would help us the more wet weather, extreme flood type events. So we are keenly interested in this topic, and many of our stakeholders, as well as reclamation decisions, are made at longer lead times, for instance, how many acres to bring into production, et cetera. So that would really be helpful, not just for us. You can see here's the other benefits to reclamation. When we're making water allocations from our projects, that would be something that we would benefit from advanced knowledge of water availability, managing flood, stakeholder planning, as well as environmental compliance. So really there's a lot that improved subseasonal forecasting would offer to reclamation. Okay, so switching over to the forecasting competition, the Rodeo as we call it, the premise here is that it's a year-long real-time competition where folks are submitting forecasts every 2 weeks. And this originated really in an interest in better predicting drought. And we had a project design team together, and really there's a lot of ways to define drought. You can take an agricultural approach, a water management approach, a meteorological, hydrologic, economic, so forth. And so it was really challenging to focus on what we were trying to necessarily predict, but everyone seemed to agree that there was common ground in some role for temperature and precipitation. And so that's really what we're focused on in this competition is S2S prediction of temperature and precipitation with 3 main objectives: advancing the science, raising awareness about the benefits to all sectors, emergency preparedness, public health. I mean, so many people could benefit from improved information at this time scale. And then, of course, providing an evaluation platform. We've got folks from USGS, NOAA, Army Corps, and of course, drought.gov involved as partners on this competition. And quickly, the structure here into the technical details is you're submitting, if you're competing, forecasts of temperature and precipitation. So it's average temperature and accumulated precipitation in 2-week chunks. So weeks 3 and 4 and weeks 5 and 6. Updating your forecast every 2 weeks, and you're submitting it on a 1 degree by 1 degree grid across that 17 Western state domain where reclamation operates. The competition is 13 months, 1 month of preseason, and then 12 months of regular season, if you will. And our competitors are trying to beat sort of standards of practice. We're calling them benchmarks. One is the CFS version 2 from NOAA's Climate Prediction Center. And then the other is a statistical forecast called damp persistence, which is fairly simple. The quick schedule here is that it was announced back in December. We started preseason in March, regular season in April. The final submission is in May of 2018, and then we expect winners to be announced September 2018. The final submission includes code, documentation, as well as a longer 11-year hindcast, just to test the method that someone's developed to see how robust it is in performing over more than just a single year. Scoring is done using spatial anomaly correlation between what was forecast and what the observations are showing. And the folks at drought.gov have put together a really fantastic leaderboard that I'll demo quickly here for us. And you can find lots of great information there. So we have 4 categories for the competition, essentially. We have 2 time windows, weeks 3 and 4 and weeks 5 and 6. We have 2 variables, temperature and precipitation, creating 4 categories. Provided you meet the performance criteria of outperforming those benchmarks, first place in each category would receive $100,000, second and third, as you can see there. And then we also are reserving for performance based on the hindcast solely. So that's kind of the nuts and bolts of this thing. So currently, where are we? Well, we've had 10 of the 26 weeks 3 and 4 forecasts have been scored. 9 of the weeks 5 and 6, they're just delayed by essentially 2 weeks because they're further out. So they're always going to be 1 scoring short of the weeks 3 and 4. But you can see here in a tabular format, we've got weeks 3 and 4 temperature, weeks 3 and 4 precip, as well as the 5 and 6 corresponding. And what we're seeing here is in temperature, we've got a couple teams that are very competitive with benchmarks within a couple of decimal places of the benchmarks. And right now they're ranked based on average score to date, which is what actually will determine their final position for the purposes of awards, but you can also rank them based on the latest submission. When you look at precip, not surprisingly, the scores drop off quite a bit. The skill is lower, but we're still seeing teams outperforming the benchmarks in all categories. So we're encouraged that there may be something to offer here as we're roughly, I don't know, a third to a half through the competition. So right now I'm just going to switch over to the leaderboard here. So I think you should be able to see the drought.gov webpage. Right now we're featured on the front page here as a news story. So if you're interested in checking out the leaderboard, you can go here. My understanding is this gets cycled out every once in a while. So the more reliable way is to go to tools, outlooks and forecasts, and then you can see the competition right here. Click on this link, you get our landing page. There's a little bit about the competition and prizes. We have a very simple leaderboard here, which is bar charts showing the top teams, top 5 teams in each category, along with those 2 benchmarks, damp persistence and the CFS. And then we have a little here. Essentially, we're updating this with respect to different interesting weather events. And so the last update talked about how it was mostly dry, except for Harvey and Texas. Anyway, the point here is that this gives you a quick view of who's leading the pack in different categories. So damp persistence for weeks 3 and 4 temperature is doing well, but also this team's still learning, and BG Zimmerman are doing well. Also, you can flip around, you get a quick view. Now, if you want more information, you can click here. And this is really where all the details lie. These are time series plots of how team scores have been changing over time for each of the 4 different categories. So you can see here that in weeks 3 and 4 precipitation, this team's salient was doing very well for a while, but they've dropped off a little bit. The benchmarks were not doing especially well down here, but they've started to improve more recently. If you scroll down, you can see those 4 tables I showed in the presentation. You can look at them based on average score, but also by the newest score, sorting them. And the last thing where you see the most information is if you pick a team and click on them, you can get similar time series plots showing their raw scores, which are the ones that bounce around more, as well as their average scores, which are smoother. So you can see, for instance, there's the temperature raw score, and then the average score, which is much smoother over time. And then below, you'll see what was forecast by the team, what the observations were, and then what the 2 benchmarks were forecasting. And this is always going to show here the most recent forecasts that were scored. But if you want to go back to, say, the first one, you go to their table, you find the link, and then it brings up what they were forecasting, and you can see that same sort of plot. So anyway, I know we're quickly running out of time here, but that's a crash course in our leaderboard for the competition. We're really excited. We think that this is going to inject a lot of interest in the topic, and we're really grateful to the folks at drought.gov who put together this really interesting leaderboard that allows you to slice and explore how teams are doing and so forth. So I'll stop there, and I guess if we have any questions.
Great, thanks, Ken. I had Ken do this because it's interesting that it's a different way of this competition method of seeing how can we improve seasonal forecasting, as well as other groups that are also working on seasonal forecasting in the labs and universities and things like that. So thanks, Ken. With that, I'll still back presentation over here while we do some questions. We had some from earlier, but before I started there, I want to say thank you to all our speakers for joining us today. And I want just to remind everyone before they pop off that these will be up, these slides and the YouTube recording and a 2-page summary will be up on drought.gov later this week. Our next webinar is scheduled for Monday, November 27th. We'll be further into the water year. We can start to see how we're doing so far then. So please tune in then. You can already find registration for that webinar on drought.gov on the calendar tab, or the info will be sent in the post-webinar email like I usually do. Going to questions, I think I saw one from Miles back for you that was back a little bit ways, was what they were wondering if your tool is available for Southern California, which I don't think it is yet, but I was wondering if you could talk about possible other regions you might be expanding to.
Sure. So yeah, the nice thing about these models that we're developing is they're not necessarily, and nothing's saying that they're specific to the Sacramento River or Shasta Reservoir. They can be applied anywhere as long as you have the data they need to run. And so we're currently working on trying to expand this on other tributaries in the Sacramento River. Right now, we're kind of just modeling the main stem, but we'd also like to incorporate other tributaries that might be important for salmon reintroduction, et cetera. But there's nothing really specific about these models that says they have to be ran in Sacramento. They could just be ran anywhere as long as you have the data to feed them, which really comes down to three things. Having good terrain information, so you can make a bathymetric map of your rivers or watershed or reservoir, and then having essentially good observations of water temperature that you're interested in order to try and calibrate some of your models. And having, we're kind of fortunate, I guess, in the Sacramento region where there seems to be lots of data loggers that provide real-time information, which really allows us to update our models daily. They can automatically ingest that information. And so I'd say as long as you have those things, there's nothing to stop it from running anywhere else.
All right, thanks, Miles.
Yeah.
There's another question which I think was for my presentation, was that the SOI graphs showed water year 2017 as a neutral year. The ONI CPC forecast showed as a La Nina. How would you classify water year 2017? To explain that, so these are the scatter plots I was showing earlier that we did the precip versus how the SOI graphs showed. So SOI is the Southern Oscillation Index, so it's slightly different, say, than maybe what the ONI CPC is using with that Nino 3.4 region, so that sea surface temperature regions in the Pacific Ocean. I classified water year 2017 as a weak La Nina year, but I want to make sure you guys, those were just what those graphs were showing, and what the Nino 3.4 region are tied together but slightly different. But I wouldn't want you to just focus so much on that negative, say, 0.5 value, which shows when we go from neutral to La Nina. Whether you're a little above or below that threshold, it's not a huge difference. It's not like all of a sudden we hit that and it's completely different conditions. So it's a little bit of a, whether you're hovering around that edge, whether what your conditions may be, whether we call it a neutral La Nina, I guess it doesn't really matter as long as we see what happens with the temperature and precip that comes along the way. So I probably wouldn't focus too hard on was it exactly this value, because it just was the larger global climate conditions setup that led to whatever we got last year versus this year as well. So I hope that helps clarify a little bit. Last question. I'm not sure. Maybe Miles, this is you again. Is the oceanview.pfeg website internal? Couldn't seem to find it online. Site doesn't allow it to be viewed.
No, it shouldn't be internal. There's the link that's on my presentation, which when you send out, people should have access to it, but it should be a public site, and you should be able to view it. Okay. I'm not sure if I could like print the questions into the URL into the questions dialogue if you wanted to send that. Sure.
I can also include it in the post-webinar email as a hyperlink so they can go directly access to it afterwards. I think too might be a good way to Google it. So we'll work around it.
Yeah.
Yep.
Okay.
Otherwise, I don't see any other questions. Again, I want to thank everyone for joining us, and thank you for our speakers. Please contact me if you guys need any more information on the drought early warning system or what you saw here today. And please fill out our post-webinar survey. We do really read those, or I really read those, so I know what timely topics and updates that the listeners are looking for, especially as we move through the different parts of the water year. It was great to have last year, and I really hope you guys keep sharing them. So otherwise, I'll end the webinar there and say thanks, everyone.
Thanks.